in the last video we had seen that the capacitor is made up from the conductor, right? We said that the capacitor is made up from the conductor. Now let's say if we take a spherical conductor, okay, let's say suppose this is a conductor, spherical conductor whose radius, let's say it's r, then how much will be its capacitance? Okay, how much will be its capacitance? Let's say this capacitor, let's say, has stored, let's say it has stored the charge of q, all right, and when it has stored the charge of q, let's say its potential was v, all right, because as the charge storage increases, the potential will keep on increasing, right? So we are taking another general case that if q charge it has stored, let its potential is v, then how much will be its capacitance? C is equal to q by v, all right. Q by v will be the capacitance of the spherical conductor, right? Now this derivation is not there, okay? One thing, for a spherical conductor, okay, suppose this is a charge stored, all right, then suppose q charge is stored, and then the potential of it is given by 1 by 4 pi epsilon q by its radius, okay. This derivation we didn't do it, okay, but we are going to use it now, all right. So what we said, if a spherical conductor stored the charge q, then its potential on the surface is given by 1 by 4 pi epsilon q by r, all right. Now the same thing, then C is equal to q, how much is potential on the surface? The potential on the surface is 1 by 4 pi epsilon q by its radius, right? Then q and q will cancel out, then what it comes? 4 pi epsilon r. This is a very important thing to know. From here one thing we can know, r implies what? R implies radius. What radius implies? It implies the size, okay, right? Bigger the conductor, larger will be its capacitance, okay. Then this epsilon naught, now conductor, all the charges will be at the surface only. In the conductor, charge cannot be outside, cannot be inside, always outside, okay. So it has nothing to do with it, right? 4 pi epsilon, it's a constant. R means what? Size. So bigger the conductor, it means what? If the conductor is bigger, its capacitance will be what? Its capacitance is big, okay. So if you want a big capacitor, you need to have a big conductor, okay. So that is only the information we need to we can get it, all right. Then in order to have, if I want 1 farad capacitance, okay, what should be the radius then? What should be the radius then? Then C is equal to, for having 1 farad capacitance, what should be the radius? The formula is what? 4 pi epsilon r, right? 1 capacitance, this equal to what? 4 pi epsilon, this is r, right? Then this become what? 1 by 4 pi, it become 1 by 4 pi epsilon is equal to r. 1 by 4 pi epsilon is what, student? R is equal to 1 by 4 pi epsilon 9 into 10 to power 9 meter. That means suppose if I have a ball, okay, if I have a ball who is 9 into 10 to power 9 size in radius, then its capacitance will be what? 1 farad, okay, very big. 9 into 10 to power 9 is near to 10 to power 10, right? 10 to power 10 is what? 10,000 what to say, no 10 lakhs kilometer, right? So if we have a big ball, which is bigger than the size of the earth, because radius of the earth has an order of 10 to the power 6, right? Isn't it? So the earth also has less capacitance than 1 farad, right? Isn't it? So I gave a question on this also. You can try it. Okay, so if I want to make a simple capacitor who is having big capacitance, then its size have to be big. So you need to understand capacitance depends upon, the information is capacitance depends upon the size in a conductor, because capacitor is made up of conductor only, right? Now I hope this is clear. This is a small derivation which is done in your note also. Now our next topic is energy store in a capacitor. Okay, now energy stored in a capacitor. Energy stored in a capacitor. Okay, will the capacitor store the energy or not? Let's say this is a conductor. Okay, I'm just taking any conductor. Now you are using this conductor as a capacitor. That means what? You are storing the charge on it. Now in the beginning, let's say you have given Q1 charge to it. All right, will it experience any repulsion? No, right? So what would be the work done in that case? Work done would be 0, right? Now this Q1, let's say you have brought it here. Okay, this is Q1, let's say. Next time you are bringing Q2, storing the charge, so it should be having the same nature, right? Q2, right? Now if you are bringing this Q2 to here, then what? There will be repulsion, right? Then what? Work have to be done against the repulsion, right? So in this case, what? Work done is guaranteed, right? Isn't it? Next time you are bringing Q3, let's say Q2 has gone against the repulsion. You have supplied the energy from outside and stored the charge. Now Q3 you are bringing more repulsion need to face. That means what? More work have to be done on the capacitor. That means all this work done. All right. As many work have been done on the capacitor, what? It stores. It store energy. All right. So in some textbook, all right, capacitor is written as a storage device of charge, or sometimes we can even write it as storage device of energy, because so many work have been done. This work will be stored in the capacitor as energy. All right. Now as it's storing the charges, so what form of energy it need to be? It need to be electric. All right. As it's storing, so the energy should be potential. Electric potential energy it is storing. And during the time of discharge, like in the fan it does, the potential energy converts into kinetic energy and all those things will happen. So this is energy device. Okay, energy storage device. Okay, so the derivation is quite simple. Let's say I will suppose here is a conductor. Let's say Q charge, when Q charge was there, its potential was V. All right. Okay. When Q was there, when Q was given, okay, V was its potential till here. Now, how much the work done, all those things, we do not know. All right. Now further, let's say further, let's say we are giving dq amount of charge to it. All right, we are giving further dq amount of charge to it. Then what will happen to its potential? The potential will further rise, let's say by dv. All right, fine.